Hello, Mike.
Hey, Kayo.
So today let's talk about decomposing code into modules.
Okay, more modular design here.
Yeah, in the previous episode, we briefly mentioned it and we got a bunch of questions.
Understandably so. It's a hard topic.
So let's use the same example as last time, where we created a FeedViewController that has a reference to a FeedLoader protocol. And then we have two types that implement the protocol. Well, three types. We have the RemoteFeedLoader, the local FeedLoader, and then we have one that composes the two. And we said that we are decomposing them into modules by using these different colors, which means there are 5 modules here. 4 of those are in our control, and one of those is UIKit.
I think we can zoom out and demonstrate a little bit better this modularity going on there.
So let's start from UIKit. That's an easy one. So this is UIKit. Let's forget about the types and let's think about modules.
Yes, exactly.
Up from UIKit, we have a view controller. And what kind of module would you add a view controller to?
Right. I think that's an easy one. It's the UI module.
Okay, so if we call the views a UI module, does it make sense to have the FeedLoader protocol as a UI element?
I guess it depends what the FeedLoader represents there. It represents a behavior that the UI requires, like a feature. So I think we can make the case of, yeah, it could be. But then again, maybe it can reside in its own module.
But for now, they have the same color as they had in the previous episode. So let's imagine that this protocol or interface, it's a boundary.
Right.
We are defining a behavior that we want, but we don't have. And we expect another module to implement it.
Okay.
So this represents a boundary, right? It's an entry point or even an exit point where messages go out and in. And this is the point that separates the modules. That's the dependency inversion. By introducing this protocol, in the previous episode, we showed how the UI stopped depending on concrete FeedLoaders.
And the FeedLoaders don't know about the UI.
Yes. So this is an entry point for the feed feature.
Yes, exactly.
So let's call this a feed feature interface, right? We can have a bunch of methods here. We can have a bunch of interfaces that will be implemented by external modules. So in this case, we have the FeedLoader, but we can have a feed item struct.
Right, as a model for passing data around from module to module.
So the feed feature interfaces are a bunch of functions, protocols, and data. It just happens that at this point, it lives in the same module as the UI.
I think that's much better to visualize in our heads probably, because now the RemoteFeedLoader depends on a feed feature rather than a UI interface there.
Yes. So what is this RemoteFeedLoader?
Right. So we know that it has some sort of interaction with a network. So we can name it as a component of the API module.
Right. So it's like the feed API module, for example.
Yes. And the local FeedLoader, it has to do with persistence. I'm happy to name it a database or something like that.
Right. A repository or a database.
Yeah.
And then we have the type that composes the two.
Yes.
It's a composer.
Right.
And we normally compose types in the main module.
It's a good idea since all the arrows come from this module and none of the arrows go towards this module. So main, I think, is a great example.
Yes. We could create an adapter module, or we could create a composer module, or we can just leave it in main for now.
Right. And we should make that clear that these modules can contain a bunch of components, right? It just happened that we showcased an example with one component, one class in each module. But in reality, they can have a bunch of them.
Yeah, the main module can have the app delegate, for example. Mm-hmm. You can have a bunch of factories and assemblers. You can have composers, adapters.
Right, exactly.
The API module can have
services,
URL sessions, services. The database can have core data dependencies or realm. And the feed feature component can have a bunch of interfaces, as we mentioned, and feed modules.
Right.
So this is a fairly common way of composing applications if you're breaking down things in modules.
Yeah, I agree.
But at some point we might say, well, I want to have an AppKit application as well. We're using those other types, which at some point we might say, well, we need to separate the feed feature from the concrete UI, because this UI is a UIKit user interface.
Right.
So you might end up with a new module, the feed feature module, where we have all interfaces and shared modules. But it's important to say that this feed feature module doesn't depend on any other module. Right? There are no arrows coming out of this, only arrows coming in. It's the boundary module.
Exactly.
Now we can have different UIs, and we are able to plug and play those modules together as needed.
And this seems great on paper, but it's not the everyday use case.
No.
However, it doesn't have to be in order to create an architecture like this, because such a design enables us to, as you said, switch modules or components without knowing the rest of the system, without depending on the rest of the system.
And test in isolation as well.
Exactly. Enables us to test in isolation.
And also, we can reuse those in different applications. But this is not normally the use case. Normally you have one application and it's iOS or only macOS, and you don't have the need to reuse these in other applications. You don't have the need to use these into other platforms. So there are other ways we can compose this. We don't have to start with this level of separation. This is maybe an extreme case where everything is decomposed in separate modules. But the point here is that it is possible to do. And if there is the need, you should be able to easily adapt, but a much simpler app. For example, the API database and the feature interfaces and models in the same module. And you can decide to separate the UI.
Right. So here we have the API, the database, and the feed feature modules with red, which denotes that they are
In the same module.
in the same module, basically. Yes, exactly. And then the UI has a dependency on this feed feature, which may create some coupling, especially between the API and the database there. This diagram doesn't show that, but it could very well be.
As long as you don't add a dependency here.
Right.
Or the other way around.
Yeah.
And as you said, you can create some coupling here unnecessarily. Maybe your UI doesn't need a database, but as long as the arrows are pointing in the same direction with the same level of abstraction, you're still able to decompose as needed. If at some point you want to reuse the API in another application, you just move it to another framework. And then if there's the need to share the database, you do the same and you go back to here. So we should be able to go from everything in the same module to separate module.
Easier said than done.
And you can even decide to put even the composer in the same module, for example. And then you don't have a main module. Or maybe the UI is the main module in this case because it's going to compose those types directly. Or you could have everything in the same module, apart from UIKit, because we don't own UIKit.
Right. And this is the case for a monolith application, as they say, right?
Yeah, it's a monolith, but it's still well separated, which means we can break this monolith as needed. And I would advise people to start probably here. Keep everything in the same module, but keep a logical separation of concerns. So if you ever need to break it down, it's easy. So there's nothing wrong with monoliths, as long as you keep your types modular inside the monolith. And as we showed in the previous episode, you have the same amount of code. You just break it down into small classes or structs or functions with clean interfaces in between them.
Right, exactly. One downside, though, in this monolith approach, and I guess this is a matter of preference, but if you're creating an iOS project, you're going to have to see the simulator. And, well, it bugs me, to be honest, having to test API components or database components through the simulator instead of having the Mac as a test target and having blazing fast unit tests.
You're saying that if we have a database module that is not in an iOS target, we can run it without the simulator.
Yes, exactly.
And we can run the tests without the simulator.
Yes.
And the same for the APIs and for any type that doesn't require UI.
Yes.
It would be much better to test those types without the simulator. But if they live in an iOS target, to run your tests, you need to boot a simulator, which is, let's say, 3 to 5 times slower or maybe more.
It's costly. And
Right.
it can add up. So it's a trade-off. You can definitely start like this if you see the need of having faster tests, which might be immediately for some people. Then you can just extract your code with these boundaries and good source code dependencies.
but you also add some overhead of maintaining separate frameworks.
Absolutely. That's one of the trade-offs.
So that's pretty much one way of composing types in separate modules. You can have all the types in one module, but as long as they are separated, your monolith is still pretty testable and decomposed. As needed, you can move those types to separate modules for usability, for testability, for faster tests, or for whatever reason you need to move them. But why is so rare to see applications that are composable or decomposable?
In my opinion, I think it's because it's harder to do so. It requires a steep learning curve there. And we often see developers wanting control of their components and referencing components inside other components without good separation, like dependency injection, initializer injection in this case, enforcing immutability.
So working with concrete types, you feel more in control. In having even procedural code feels like you're more in control because you can see line by line what's happening. But as soon as you start using dynamic dispatch and start using interfaces and closures, people start getting afraid.
Yes, absolutely. So for the untrained eye, perhaps it's harder to think abstractly. For example, invoking a closure in a function instead of having an implicit dependency of a singleton, let's say, and invoking the singleton's function directly, as we covered in previous episodes.
Which would lead them probably to have an architecture, as we commonly see in iOS applications, where we have the UI talking to a concrete model layer. That could be a view model or a presenter that then talks directly to another concrete API or a concrete database that could be singletons or it can be injected, but they are concrete and they're not very easily composable. You might have a chance of injecting different behaviors by subclassing, but you would see UI kit elements in the model layer. You might even see UI kit elements like UI images in the API or database layer, and there's no clear separation of concerns. Sometimes you see the UI fetching things from the database directly or the API. It's often the case that we see UI elements accessing databases and APIs. For convenience, it might be easier at the time or faster, but you quickly lose control, the so desired control you wanted in the beginning.
Yeah. And I think in this example, the problem is the lack of proper communication between these modules, where there are no predefined communication channels. Maybe they're going to be bidirectional or single direction communication between the model and the UI, or the UI and the model there, the API and the model, the database and the model. So we're going to see components being referenced all over the place, the UI in the database or the database in the UI. And this can create tight coupling and confusion and rigidity as we go on. The so-called spaghetti architecture.
Yes. And to be fair, you can still have a concrete architecture. There's not a spaghetti. If you keep the layers separated like this, it might work well for a majority of applications.
Absolutely.
Depending on the application I'm working on, if it's very simple, I would probably start like this. But I know how to go from this architecture to something more modular. And I would do the transitions as needed, backed up by tests, backed up by the compiler. So there's nothing wrong with starting like this or having an architecture that is super monolithic and start breaking it down as needed. You don't have to start with a very modular application. And again, a modular application doesn't need to be complex.
Yes, that's very important. If we follow good principles, we can end up with a pretty good architecture there.
I've seen code bases that were monolithic and they were very concrete, but they were easy to change. They were easy to work on. They were tested. You just need to understand the trade-offs. You need to understand the problem you are trying to solve and tailor the solution.
Yes, that's the most important thing to remember, that there's no holy grail, right, for architecture or design. You need to tailor it to your own needs. As my friend likes to say, you can't fit both feet in one shoe, right? You need to tailor it to your own requirements. And it's hard. It's definitely hard to do so.
So my advice is to learn different approaches. Because the more you know, the more options you have to solve problems. We have problems and we find solutions. We don't settle with lesser value.
Yes, absolutely.
For example, going back to our super modular approach, we can then have another module that is an assembler, a builder, or a factory that composes everything together.
Whoa, that's a lot of dashes and a lot of arrows there.
and it might look complex, but when you translate this to code, is 4 lines of code, 2 lines of code, or 1 line of code. It's not that hard. It's simple. If you can achieve the same level of separation by following OO principles or functional principles.
Yeah, I agree 100% with you. It might seem complex, but it's not. It's simple, and it's worth testing it out by yourselves.
So I think that's it. So I hope you enjoyed this video and learned something today. Don't forget to subscribe and check the links in the description.
And we'll see you again next time.